Hello. Thank you. Thanks for coming over. It's a bit early on the first day, but never mind. My intention is to give you an insightful briefing in developing sustainable, high-performance, high-tolerance concrete floors. We'll look at some of the considerations needed by traditional MHE, as well as the current trends required by the more modern automated MHE. Initially, I'll give you a quick brief intro to the CoGri group to clarify our knowledge base, which allows the group to bridge the gap on an international basis between the MHE providers and the contractors. So these will be the main topic headers, but we'll touch on a lot of other topics in between as we move along. So 1 and 2, quick intro to the global group and Asia in particular, highlighting the areas where we provide support to owners, developers, consultants and contractors. The global flooring market as it currently stands, traditional MHE concepts and current flooring trends, floor design considerations, which applies to both the traditional and automated MHE, but with varying degrees of significance. Floor construction techniques and highlighting some of the significant differences and implications. What are the control parameters, to ensure we get the right flatness? Some common defects found across the globe, sustainability with respect to floor construction, and finally, a few regional project references and clients. Yeah, right. Okay, so across the group, these are the main activities undertaken globally. Number 1, design consultation, surveys of high tolerance floors. Surveys undertaken using our own digital equipment, designed and built in-house. So this photo here shows one of our profilographs surveying a VNA aisle, very narrow aisle, to a defined movement specification. Construction of high tolerance floors. These can be design and build or simply construct to a consultant's design. Steel fiber reinforced concrete floors are generally the design and build option on pile or on grade. Also conventional reinforced bonded, unbonded toppings, freezer and cold room slabs. Automation concrete flooring. Often there's a bonded topping to existing floors, some of them requiring very high tolerance, which we'll look at shortly. VNA laser grinding, using the group's patented laser grinder. VNA machines now can lift up to 18 meters, which at DM1, defined movement 1, requires a 1.5 millimeter tolerance across the wheel track. Now that's the thickness of a 50-cent coin. Finally, number 5, repair and refurbishment may be needed in heavy traffic zones, particularly at joints. If it's a low quality floor, then numerous zones may need repairing. And it's always good to remember that it's better to spend your capital on long-lasting floor repairs rather than the equipment repairs, and also it's obviously going to improve the efficiency of your operations. Finally, wire guidance. This is required by certain VNA trucks. Alternative to the wire guidance is rail guided, where the steel guides are fixed to the racking legs. The 3 primary group entities are face consultants, providing the design services, floor consultancy, QA, QC management, testing, surveying services. The CoGri entity represents the contracting arm of the group, undertakes floor construction, laser grinding for VNA, and robotics grinding. And then finally, CG Flooring undertakes all manner of floor repairs, including high-strength industrial screeds. So globally, the group has a large footprint, but we're actually quite a small organization of about 200 people. We have 25 offices worldwide, with a couple more opening in Portugal and Italy shortly. And a second office has opened in the USA in Phoenix. Yeah. Okay. Across Asia, the group has offices and partners in 9 countries. We're headquartered in Singapore, and we've been in Asia since 1993. Thanks. So that's 30 years now that we've been operating in Asia. So headquartered in the UK, the CoGri Group, we bring a global knowledge as your local partner. I want to add here that Face Consultants is carrying out third-party surveys and testing. It's not just a group company that surveys our floors. So anyone can engage them to survey their concrete floors, as well as provide design services. In Asia, Face is represented by Face Consultants Southeast Asia in Singapore and KL, Face Consultants Korea, and Face Consultants China. For CoGri, it's represented by CoGri Asia Pacific in Singapore, CoGri Korea, CoGri Hong Kong, CoGri Malaysia, and more recently, CoGri Japan. The group started as concrete grinding way back in 1989. And by 1992, the proprietary laser grinder had been developed. By 1993, we saw the first laser grinding project in Asia. And by 2000, we were constructing super flat floors. By 2007, automation projects kicked in Asia. So this is what this show is all about, is automation. So our support for owners, developers, and consultants, design and build construction options, early budgeting for their projects, programming, specifications required for operational side, pre-qualifications of specialists, QA, QC, and generally future-proofing so as to align with potential automation solutions. And overall, these are going to give a cost benefit to anyone undertaking these services. For contractors, we're talking about value engineering. We're talking about different alternative solutions to the flooring. Now that could be steel fiber reinforced, could be topping, could be wide bay construction up to 2,000 square meters, or it could be long strip for defined movement, VNA traffic. Program acceleration. Some of the construction methods will dramatically speed up the overall construction schedule. Cost minimization, we want to make sure that the floor slab is as thin as possible and with minimum amounts of reinforcement. Resource sharing with the main contractors. They'll often give us direct support, whether that be labor or other side items. green mark enhancement. We see that more in Singapore than maybe elsewhere around Asia. But there's various schemes now where contractors need to achieve a certain amount of green mark score, and this our flatness tolerances add to that. And then finally, sustainability. I'll touch on that a little bit later. So today the marketplace is split between traditional MHE and the newer automation. Although, as I say, it's been around since about 2016, 2017. Traditional material handling equipment, they know their specifications, but they're not able to translate this to contractors. However, on the automation side, neither do they know their specification requirements, and neither can they translate this to contractors. This is portrayed by a China spec that you may see on a regular basis of plus or minus 4 millimeters. I've put it down there, over 2.25 square meters. Now you've got to think about that. How do you measure something over 2.25 square meters? We don't know, and we've never met anyone that does know. So we often ask when someone brings this up, what do you actually mean by this? What are you trying to say? They have no idea. So the CoGri group are in a privileged position of working on MHE working parties and are bridging the gap between these MHE providers and the people responsible for building the floor. So for the last 30 years and more, there have only been two questions that we ask when determining a floor design. What is the floor being used for? And what are the loads? These answers then tell us whether the floor needs to be designed to a free movement specification or a defined movement specification. Now, just to clarify between the free movement and defined movement, if you don't know, these smaller trucks, reach trucks, anything with a wide aisle in a warehouse is going to be a free movement floor. The picture there shows a V&A truck. You can see how narrow it is, and that is a defined movement floor. That truck only moves in the same direction, backwards and forwards all the time. And that's the one that's the high tolerance. You can see the wheel tracks. That's actually a three-wheel truck. You can see there are 3 lanes where that truck is moving. And the tolerance for a very high lifting truck is going to be 1.5 millimeters, as I said, across that wheel track. There are generally 3 standards that you can look for. The UK Technical Report 34, referred to as TR34, the American standard ASTM for free movement, and ACI FMIN for defined movement, and then the German standards 18202 free movement, 15185 for defined movement. There are a couple of other specifications that you may come across in Malaysia. I haven't put them up here. SR1, SR2, SR3. Now this comes from a British standard 8204, and it's for general floor tolerances. They're covering offices, small, light industrial sectors, this sort of thing. If you actually read the document, the SR1, 2, and 3 does not apply to high tolerance flooring. Okay? 8204 refers directly back to TR34 if you want a high tolerance industrial floor. Now with added automated MHE, there's maybe more uncertainty over what the warehouse use is going to be. Being able to provide maximum versatility to the warehouse end user is vital for new developments. Therefore, it's even more imperative that a good FM2 floor is provided as a minimum requirement. This will provide maximum versatility for wide aisle operations, which can be upgraded to VNA aisle operations and ultimately upgraded to automation at the minimum commercial impact. A few design considerations. Settlement, whether that's ground bearing or pile supported, we still need to consider what the settlement's going to do. And I've made a note there with regard to ASRS systems, FEM standard. The deflection criteria is extremely onerous for FEM, and it requires specialist knowledge. Point loads created by the racking. It's important that we also consider the point loads, not just the UDLs on the floor. Flatness specification may impact design considerations as well as construction methods. Creating a crack-free floor can be achieved either through saw cuts to induce cracks or allowing free shrinkage, as in the case of steel fiber. Joint openings are used to relieve the drying shrinkage stresses of the concrete. It needs to be noted that the cracks are caused by restraint to drying shrinkage. So taking away the restraint will allow your concrete floor to shrink and not to crack. Now, it's easier said than done, removing all cracks. But with joints, we don't want them to open up to the extent that it affects the material handling equipment. Automation is much more susceptible to joint width than the bigger trucks are. Armored joints protect the slab arises from deterioration and are absolutely essential for steel fiber reinforced concrete floors to allow the free shrinkage. Finally, adequate power troweling will provide good abrasion resistance without the need for any dry shakes. Dry shakes bring their own inherent problems if not used carefully. Chemical or wetting and covering will help provide a sustainable surface free of defects. So floor construction techniques now, quickly. So the techniques are needed to follow on from the good design practices. You need to provide both of them for high performance, high tolerance flooring. Conventional slab on grade that we see there will require saw cuts to induce the cracking, but you cannot guarantee no cracking unless all forms of restraint are removed. And that's very difficult when you've got columns in the middle of your floor. So it means you've got to deal with the column penetration separately. Slab on pile is a different consideration because your reinforcement is going to be a lot heavier to span between the piles. So that reinforcement is very difficult to yield, and you're not going to put saw cuts in. Your reinforcement will control your cracking. Steel fiber, we mentioned, can be either slab on grade or slab on pile, and you must allow it to shrink freely. We've already discussed that with the armored joints, and you've got to make sure all your restraint is removed to allow that concrete to shrink. Now, there's a number of high-profile failures across Asia where the restraint has been not removed, and the slabs have cracked extensively to the point of being unusable. So if you hear stories about steel fiber not working, then you need to really talk to a specialist, because steel fiber is a great way forward. We do a lot in Malaysia, we do a lot in Korea and Thailand. For suspended floors, so we're talking about upper levels, we need to be looking at a bonded topping, which can either be structural or non-structural, depending on the engineer. It needs to be carefully noted, though, that bonded toppings are fully restrained, and therefore they will crack. Okay? We still get questioned today. that there's going to be no cracking in bonded toppings. It's absolutely fully restrained. It's mechanically bonded to the structural slab. It's not going to shrink freely. It's going to crack. And the rebar that we put into the topping is there to control the crack width. So commonly, toppings are generally about 100 millimeter thick, but there's also additional considerations required for precast and post-tension structures. Finally, the flatland specification will also influence construction method. Free movement will allow large pour sizes of around 2,000 square meters in a single casting. For defined movement, we're obviously looking at a much tighter tolerance. We've got two methods. Long strip, that's basically where the width of the casting will match the VNA aisle positions. If the aisle positions are unknown, then we would carry out what we call a cast grind, which is basically casting to a free movement specification and then laser grinding the aisles once they're known. So in summary, construction options are steel fiber, what's called jointless, but as I've put there, it actually means less joints. Free shrinkage with the armor joints. We've got our mesh reinforced slab on grade requiring saw cuts and the restrained bonded toppings. Now we have to consider what we're going to do dealing with the automation. Now this is a discussion that may be had today or sometime in the future. But the cost will heavily depend on what you're constructing or how you're constructing today. For general AMR movement, a good quality FM2 floor may be sufficient, although there are still many systems requiring a bespoke specification. One of them right here behind you. We work closely with Geek Plus, we work closely with High Robotics, and a lot of the major robotics companies to get their specifications right. There's a lot that goes in the background with these systems. Obviously, you've got all of the software, but if the floor is not right, then the systems are not going to work efficiently. If you don't believe me, go and speak to these guys. They'll tell you. We're also seeing a lot of new automated products being released almost on a monthly basis. Some of the latest AMRs are picking at 13 meters high, which is closer to a VNA operation. And these AMRs require a defined movement specification. An alternative to the floor running systems is the auto store system on the right there. Whilst these robots, they run on a grid, an aluminium grid, the bespoke specification is extremely tight. And that's because all of the boxes which are within that metal grid are sitting on the floor. And if that stack of boxes gets inclined, and then they won't lift out of the aluminium grid. So we're actually building a floor to suit the boxes rather than the robots. We did recently in Singapore, we cast 3,000 square meters of floor for an auto store project. We cast every single panel to an FM1, which is the tightest specification for free movement. And we then had to hand grind that FM1 floor into specification for the auto store. That's tight, okay? So in summary, you need to be providing a minimum FM2 floor. Anything less than that is going to cost a lot of money to upgrade for automation. So then the question is, if we have a good quality FM2, what are we going to do to upgrade it for automation? By far the most economical upgrade method is remedial grinding. That's this picture down here. You can see how much grinding they're doing to that floor. This method may be required on a new floor, so should not be considered a defect remedial. However, to achieve remedial grinding, the floor flatness does need to be pretty good. For floor errors, floors with errors up to approximately 15 millimeters, we can do a high-strength industrial screed. Beyond that, you're looking at a concrete topping. So that's poor quality flooring. We're going to add an extra 100 mil topping onto that existing floor. So keys to high performance floors. From CoGri's perspective, there are 5 pillars, as we call them, that we need to control for high tolerance. First pillar, we've already mentioned, design and detailing, making sure that we're minimizing the restraint to the shrinkage of that floor. And if we're not minimizing it, then we're using the reinforcement to control the cracking. Second pillar, material technology. This includes your concrete mix, your fibers for steel fiber slabs, steel joints, etc. Now this is where a lot of so-called flooring contractors fall down. Concrete mixes for floor slabs is very different from a general structural concrete. Flooring concrete needs specific aggregate gradings to ensure water and air is released in a timely manner. And we also want consistent setting times to aid finishing. Third pillar, experienced people. People that know and understand what's required from the procedures, and people that know what concrete's all about. Fourth pillar, methodology and equipment. Methods that are tried and tested and carried out without shortcuts, and equipment that is well calibrated and maintained. Fifth and final pillar is the environment that the floor is constructed under. As engineers, I hope there's plenty of engineers in this, we all know that sun winds will accelerate the hydration process. This weakens the slab surface. And if we're casting outside in the open air, then there's a high chance of rain washing away the cement paste, again weakening the surface of the slab. So the fifth pillar of controlling the environment means we need to be casting internally, protected from the elements. And with these 5, if you lose control of one of these 5 pillars, then there's a high chance that you're not going to achieve your high tolerance, high performance floor. And this is what we see when we're missing one of those 5 pillars. So these are common defects that we see globally. This is not just an Asia problem, it's around the globe. So starting on the left-hand side, we've got joint deterioration. So as the traffic is moving over, it's unprotected, the joints are falling apart. We've got uncontrolled cracking in the second picture. Poor detailing around the loading dock. Restraint cracks coming from your column corners. Obviously, poor flatness. Poor abrasion resistance. This is where we're losing the cement paste on the top of the surface from the rain. Overloading is the next picture along. Load transfer, we can see here the 4 corners of the slabs. There's no load transfer, so as traffic's moving over it, the different slabs are moving in different directions. Curling. Curling's a natural phenomenon when it comes to concrete. And the thinner your slab is, the more it's going to occur. The easiest way to describe what curling is in concrete is if you place a piece of bread on your kitchen countertop, okay, and you leave it overnight, and that bread is going to curl, right? Now, that's exactly the same as what happens to concrete. And that's because moisture is being removed from one surface faster than the other surface. So your top surface of your concrete or your bread is losing moisture, then the lower surface, and your surface is, or your slab, your piece of bread, is then curling. Finally, delamination. We all see a lot of this across projects. That's basically air and water getting trapped in or under the surface of the concrete slab, and you end up with the surface cracking away and looking like that. Now, these defects, okay, virtually all of these occur primarily due to poor detailing, poor specifications, and lack of expert floor knowledge. These are not structural design problems. The only one that might be is the overloading, okay? But the rest of them are not structural design issues. So if there's any structural engineers out there, I'm with you. Finally, some new automation problems. So this is caused by automated MHE. Now, during the early years of establishing the specification for Amazon AMRs, okay, they insisted on the concrete surface being ground to increase the friction. So you can see here, all the concrete paste has been ground away and the aggregate is exposed. So we're increasing the friction. But while we're doing that, we're weakening the abrasion resistance of the slab. And this breakup in the middle of the slab here, in the middle of this picture, occurs below the AMR snapcaster. Now, the snapcaster wheel changes as the AMR changes direction, and it snaps into a new direction. And this snapping motion occurs in exactly the same place thousands of times a year. And it's breaking the concrete up because it's got a weakened abrasion resistance. The second photo shows what happens when these AMR wheels are running in exactly the same alignment day in, day out on the surfaces of reduced abrasion resistance. So a summary of providing high-performance flooring. What's the client's purpose and use of his warehouse? What's the equipment that we're going to deploy? Is it free movement? Is it defined movement? Is it automation? Defining the racking requirements will also help in defining the equipment. If it's an existing floor, get a survey done. They're quick, they're inexpensive. Find a dependable, honest flooring specialist. Of course, I'd say that. And then understand the importance of controlling the 5 pillars. Carbon reduction and sustainable construction are modern concerns affecting many corporations. Sustainable floors are ones that are constructed with minimum concrete and reinforcement, that they have an economical design with good detailing, and it's a well-executed construction giving you a high tolerance. And that is going to give you minimum maintenance. Okay? So finally, a few project references. If we get that. Oh, that's a client list. So you can see Geek Plus right at the middle there. Our good friends from Geek. High's up there. Yep, I can see High Robotics. HIK's up there. Swisslog. Amazon. All these guys providing you automated solutions. A bit of laser grinding for defined movement 1 classification. Taiwan and Singapore. This is a little bit of an unusual one at Universal Studio. A lot of these kids' rides actually need a very high tolerance floor. The trucks, the little cars that they're sitting in don't have any suspension. So if the floor's not good and flat, this is the American standard F-min, they're a terrible ride and they make you sick. Super flat. Oh, that one quick moved. Kamanjaya, down in Indonesia. BMW, Malaysia. Steel fiber slabs. Sri Lanka, we've finished the bigger project, 72,000 square meters for Michelin earlier this year. All steel fiber, slab on grade to FM2. Republic of Korea Air Force, minus 50-degree testing bed. That was very challenging. Hypermart down in Indonesia, a large part of the Matahari group of supermarkets. And obviously nowadays we're seeing a lot of multi-story construction. So a lot of topping slabs needed for these situations. Thank you. If there's anything you don't understand, do come and talk to us. We're at J35. We're quite happy to talk more and tell you what your problems are and how to solve them. Thank you.